let's actually do a problem with our first derivative test. Now this first derivative test is used to find if an equation, or I should say where an equation is increasing or decreasing. Now here's the procedure for it. Let's go through all these steps. You're going to find any domain restrictions, find all your critical numbers, which from review from last lesson, a critical number is where the derivative is 0 or where the derivative is undefined. But domain restrictions do not count. By the way, quick reminder, domain restrictions are if it says like only do it on this domain, only do it from 1 to 5, not the whole thing. That's your domain restriction. Then we create a number line. We do a sign line, label the signs on our number line, and then list our answers of increasing and decreasing with brackets, not parentheses. So let's try this out on number 1. So first step, talk about any domain restrictions. We don't have any domain restrictions in number 1, so we're good to go on there. So then we're going to find our critical numbers next, which is where f prime of x equals 0 or undefined. So let's start by finding f prime of x. Take the derivative. We're going to do chain rule on this. So derivative of the outside times the derivative of the inside. And let's simplify this a little bit so it's easier to work with. So it looks like I got a 4/3 x. Actually, let's do it this way. Looks like I got a 4x on top and then a 3 cube root of x squared minus 9 on bottom, because I take that 1/3 down to the bottom to make it positive and then turned it back into a root. Okay, now let's do where it's 0 and where it's undefined. So let's start by setting it equal to 0. So if I set that equal to 0, I would multiply by the denominator first, which is actually, since it's timesing by 0, just going to make the denominator go away. So I have 4x equals 0, and then divide by 4. So it looks like the only one I got from that is 0. That's my first critical number. Now let's look where it's undefined, aka where we have asymptotes, aka where the denominator equals 0. That's kind of your shortcut for undefined, where the denominator equals 0. So let's solve this one out. I'm going to cube this. So we get x squared minus 9 equals 0. Add 9. X squared equals 9. Square root. So I get x equals plus or minus 3. There's my other critical numbers. Next, I'm going to test these out. So I'm going to include 0, -3, +3, all my critical numbers. And now we're going to test them by finding out if the derivative is positive or negative. Now I am labeling this sign line to show that this is a sign line for f prime, not for f or f double prime or anything like that. So let's pick some numbers, plug them into f prime and see if they're positive or negative. So let's try this first one. F prime of -4 is going to give me a negative on top. 4 times -4 is a negative. And then 3 times cube root -4 squared would be 16 minus 9. That's a positive. Cube root of that is positive, times 3 is all positive. So negative divided by a positive, that's all going to be negative. AKA, that's all going to be decreasing. Because remember, if it's negative on the derivative, it's decreasing on the original. Okay, let's pick another number. Let's say -1, because we want to do this interval now. So I have 4 times -1 is a negative. I have negative 1 squared is a positive 1, minus 9 is a negative. Cube root of a negative is still a negative, times by 3, still a negative. So I have a negative divided by a negative, going to be a positive, aka that means the original is increasing, because if the derivative is positive, the original is increasing. Okay, we have 2 more numbers to test. I'm going to do these ones a little more quickly. So f of 1, if you plug that in, you should get a positive over a negative. So that one's going to go back to decreasing. And f of 4, you should get a positive over a positive, which is going to be a positive, which is going to go back to increasing. So we can say that this function will be increasing from negative infinity up to negative 3 bracket, from what we learned in the last video, and from 0 to 3, right there. And it will be decreasing from negative 3. Oh, that was decreasing, wasn't it? Here, let's just change that. Got my colors mixed up. There we go. That should be right, right? Decreasing, increasing. Okay. Now, one other thing. If you read this example, we only did the first thing. We found the increasing and decreasing. It also says, find all local extrema points. So that means it wants us to find the maximums and the minimums. So if you look right here, on this little increasing, decreasing graph I drew, I have 3 points that could be maximums or minimums. And it's kind of easy to see if I've drawn this orange and blue part. I am going to have a maximum at 0, something, at x equals 0 right there. I'm going to have a minimum at negative 3, something, right there. And another minimum at 3, something, right there. Now remember from what we learned in the last lesson, you need to read the instructions carefully. That's why points right here is underlined. If it had just said find all local extrema, then we would just want the y values. So we'd take these x values, plug them into the original to get the y values, and we'd be done. If it said find the x values of all local extrema, then it would be x equals 0, x equals negative 3, and x equals positive 3. But this one specifically says find the extrema points. So that means I have my x values. Now I need to find my y values by plugging these in to the original. Not the derivative, the original. So I'm plugging these into the original to see what I get. So 0 squared is 0, minus 9 is negative 9. And then I'm going to have negative 9 to the 2/3. Now let's just leave it like that, because we don't have to simplify things, right? Okay, let's plug in negative 3. Negative 3 squared is 9. 9 minus 9 is 0. 0 to the 2/3 is still going to be 0. 3 squared is 9. Minus 9 is 0. 0 to the 2/3 is still 0. So that right there is all my answers. The increasing and decreasing and the relative extrema. So that's all for number 1. In the next video, we'll try a couple more of these.